So your mass should again be somewhere there, but everybody got you subtract out. That's why it's, to me it's a little bit more accurate that we measured the mass at the end rather than just assuming that we had 100 milliliters of water and then the 2 grams or whatever we added in. Measuring the mass gives you the exact mass rather than using density and all that stuff. Specific heat is there, change in temperature. Now, how much was your change in temperature? About 5 degrees? Okay, but how many decimal places do we have? 1, right? Don't we just, didn't the lab quest just give you 1 decimal? Okay, so when you subtract, it's 4.7, 5.0, whatever. So you only have 2 sig figs in your delta T. Even though it went from 21.4 to 26.5, you know, it's still just, when you subtract, you're only going to get 2 sig figs. Now, because this asked for a set answer, I would probably give it in 2 sig figs. However, to carry through, I like to carry at least 1 extra, just so we don't round off and then round off again and then round off again. But technically, you would have 2 sig figs. So somebody just randomly, Sophie, what did you get for your final answer Q?
Like
Yeah, all your digits.
1,855.5.
1,855.5, and that's joules.
Choose how that is inside two.
2,032?
Yeah. Wait, what's the reaction?
What mass of your solution did you have? 99.33? Yeah. Okay?
Oh, we subject the cup?
Yes, you have to subtract the cup. Because we don't care if the cup didn't, we're assuming the cup didn't absorb or release any energy. Okay? So the cup was just a container, only the water. We're assuming only the water changed, absorbed the heat. Okay? The water and then the sodium hydroxide. Okay? And then you change in temperature. Okay? So 1855, so that's joules. So that's number 2. That's how much got absorbed by the water. Now it's easy to change that to kilojoules. Just move the decimal 3 places. So for number 3, my delta H of the reaction is going to equal negative 1.8555 kilojoules. Now you could drop off some of that if you wanted to. You really, since 2 sig figs, I'd just carry 3 maybe. Okay, but if you want to carry it all, that's fine, and round off at the end. But how much sodium hydroxide did we actually cause? Well, how much actually caused that change? Was it a mole? Because the answer, they want you in kilojoules per mole. Was it a mole? Did we use a mole of NaOH? No. How much did we use? So exactly how much NaOH did you use? 2.05 grams. So this is 2.05 grams of NaOH. So this much heat was released when 2.05 grams of NaOH was dissolved. But we want kilojoules per mole. So what do we have to do? Change it to moles. Well, what's the conversion factor grams to moles? Molar mass. So the molar mass of NaOH is 40. So I can say 40 grams over 1 mole. Grams cancel, gives me kilojoules per mole. Now, that's one way to do it. If you wanted to do it in 2 steps, you can just go 2.05 divided by 40, and that's going to give you how many moles, and then just put moles on the bottom and go kilojoules divided by moles equals. In other words, you can just change 2 grams to moles separately, and then go kilojoules divided by, it's going to come out to 0.05, somewhere in that range. Okay? So that gives you how many kilojoules per mole, negative kilojoules per mole. Okay? So whenever it's saying calculate the delta H, you have to pay attention to the sign. Sign is important. Okay? The sign's important. When it's talking about the heat absorbed by the calorimeter, this is the positive heat. Absorbed is going to be the positive. That's going to be this parenthesis part. Okay, so again, we're just trying to break down the words. So now you should be able to do this for the other two reactions. Okay? Go through and calculate the amount absorbed by the calorimeter. Change it to kilojoules. But on the third one, we didn't have grams. We had milliliters. How do you change solution volume to moles?
Is that molarity?
The molarity. Remember we had to record the molarity? What's the molarity of our solution?
5 or 1.
Dude, that one, the number 3 was 1 molar.
Yeah, no tell you what.
Okay? But it's 1 mole. What are the actual units on molarity? Moles per liter. So what unit does volume need to be in? Liters. So just remember, molarity, moles per liter, times liters is going to give you moles. So again, you can either do it this way, or it might be might make more sense for you to just convert it, your 50 milliliters to moles, and then divide it into whatever kilojoules you get. Okay, so let's go ahead and do that. So go ahead and pause.